mentioned earlier that you can define functions in line. That just means giving the entire function definition within the class itself, but it's better if you put the definition below the class, outside or below the class. And this is the reason why. Because you can separate the class and all of the function declarations into one file, and you can put all of the function definitions in a separate file, and then you can just include that header file into main. And this makes the class not only more flexible, but now I can use that class, that exact same class, across multiple files if I want to. So this is what it's going to look like. First of all, we're going to create a header file. We're going to call it the name of the class. I'm going to use a pound if in def and then pound define as the preprocessor directives. And then I want you to notice at the bottom we have a pound in def. So we're going to create what is called a header file, and then inside of there I'm going to have my class along with all of the data members and the functions. And if there are other function definitions, function declarations that I want to include outside of the class, I can put this in the header file as well. And then after, we're going to create the implementation file. It's going to have the name of the class, .cpp. I am going to use a pound include with the name of the header file, and then I am going to give the definitions for each one of the functions within the header file. In order to be able to do that, we're going to use the class name, with the name of the function. Now the very first one under the definition is the constructor itself, and then it looks like I have a couple of functions in here as well. If I have included other function declarations in the header file that are outside of or perhaps below the class, I could put those definitions in this file as well. And then we're going to have some kind of a main file. And this main file is going to be using the class that we created. So now I'm going to do a pound include with the name of the header file. Notice these are surrounded in quotes and not the chevrons that we're used to. So I'm going to pound include the name of the header file, and then I'm going to use it exactly the same way that I would have when we were creating the class, right there in the same file itself. So let's see what this would look like if we separated out or created multiple files. For teacher, we have a header file using the f and diff and the define, and then the indif at the bottom. We have defined the teacher class along with the function declarations. Then we're going to create an implementation file called teacher.cpp that does a pound include teacher.h in the quotes, and there I'm going to define each one of the functions. So we're going to have let's say that we're going to default our constructor, and then we're going to have a couple of other functions that are in there. I showed you what it looks like for pay parking tickets. Notice that we use the class, the name of the function itself, and then this is what our main file might look like. We're going to pound include teacher.h again, and then I'm going to begin to instantiate and use objects in there. So how about if we do this with a student file? Notice that this, instead of the if and def and the define, has a pound pragma once. We can use pragma once to replace the other three preprocessor directives. Both of these, what we were using before, and the pragma once, are used to prevent multiple inclusions of the same header file, so that we can, that could cause the redefinition errors or other issues. And so we're trying to stop that with the if and diff, the define, and the indif. They're also known as inclusion guards or header guards. Now we can replace that with pragma once, pound pragma once. It is a non-standard guard, but it is widely supported by modern compilers. It's a whole lot simpler to use, and it can lead to faster compile times because it allows the compiler to use its own internal cache. But not all compilers will support it. So not all compilers recognize it. The original, the if and def, the define, and the ndef are standard, which means they work with all standard compilers, and they don't rely upon specific compiler features, but it's a lot longer to write. and read, and it's prone to errors such as allowing inconsistent or duplicate macros. So the best practice, which one do I use? You want to use the Pragma once if your code is only intended to be compiled with compilers that would support it. It's simpler. Now all modern day compilers would support it. You want to use the original if and def if you need maximum portability across all compilers, because it will work with any C++ compiler. I guess another option is you could use both of them. So you could put the Pragma once at the top right above the pound if and def. So if it is supported by the compiler, it will use Pragma once. If it's not, if Pragma once is not supported, then it would use the regular header guards. All right, so let's see what our implementation file would look like. We're going to, again, pound include student.h and double quotes, and then we're going to begin our function definitions with our constructor along with some of the other functions that we might be creating, and then finally our main file where we're going to instantiate and use objects of the student class. Now I said it's so much more portable if you are creating separate files for your classes, because here's an example of maybe I'm going to create a university program that needs to include both teachers and students. So now I notice how my main program is not cluttered with class definitions and function declarations. Instead, I can just pound include the two header files that we have already created, and then I can begin to use them in my program. So how about if we put some of this into practice? We're going to create a new mouse class. It is, and here's an example of a UML diagram for my mouse class. It's going to have three member variables, and it's going to have some member functions. I see that there is a constructor in there. There's actually some other functions, and then it looks like we have a couple of getters. And we have a natural setter called set growth rate. That's just a natural function that I needed to use in the class. So we're going to create a mouse class, and we're going to practice some of the things that some of these utility functions that we have been doing.